Orthogonal trajectories, polar curves.
Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir. In today's video, we are going to solve problems on orthogonal trajectory of polar curves. So in the previous video, we had solved problems on orthogonal trajectory for Cartesian curves. The method of finding the orthogonal trajectories of polar curves is different from that of the Cartesian curves. So let's see how the method works, and based on this method, let's solve some problems to understand the concept better. Polar family. See, basically a polar curve is something which has radius and angle theta. So the curves like r is equal to a into 1 plus cos theta, r is equal to a into 1 minus cos theta, r is equal to a raised to n cosine theta, r is equal to a raised to n sin theta. These are all polar curves. Okay, so let's write the general form of a polar curve as r is equal to f of theta comma c, where c is a constant. Okay, so for any polar curve, the method of finding the orthogonal trajectories is very simple. Okay, so when we are considering any polar curve, when we are solving a question of a polar curve, the best practice is to apply log on both sides. Okay, for that I request you to please visit the playlist and check out the videos for the polar curves, that is module 1. It will be very helpful here. Okay, now I have r is equal to f of theta comma c, that is c is a constant. So for this, first what you do, apply log on both sides. After applying log on both sides, we differentiate with respect to theta. Okay, next the main step here, the main step to find the orthogonal trajectory of a polar curve is replace dr by d theta by minus r square. Listen carefully, minus r square d theta by dr. This is the main step here. After replacing, you solve the equation. So when we solve the equation here, we get the required orthogonal trajectory. That's it. So the main thing here, they will give a question r is equal to f of theta comma c, whatever it is. First, the best practice is to apply log on both sides. First, then principles of log, then you differentiate with respect to theta, then whatever you get differentiation in that, replace dr by d theta by what? Minus r square, lend derivatives to mean. You will make confusion here in the exam. Replace dr by d theta by what? Minus r square d theta by dr. Replace dr by d theta by minus r square d theta by dr. Then solve the equation. The result, what you get is the orthogonal trajectory for the family of polar curves. That's it. So to understand the concept clearly, let's solve some problems in a very easy way. Okay, so that you don't lose any marks here. And remember, questions like this, they ask for 67 marks in the VTU examination. So be with me till the end. Watch everything carefully. Practice with me. With your, you bring your notebook, your pen and paper, and practice along with me so that you don't lose any marks here. So let's make the solution of orthogonal trajectories very easy and simple by solving some questions. The first question is, find the orthogonal trajectory of the family of curves r is to n is equal to a is to n cosine theta. Okay, so let's first write the curve here. We have r is to n is equal to a is to n into cosine theta. So what did I tell you in the first step? While you are dealing with the questions of polar curves like r and theta, always it's the best practice to apply log on both sides. Things will become, the solution will become very easy for you. So first what? Apply log on both sides. So log of r is to n equals log of a is to n into cos of n theta. Right? Now apply the principles of log. Everything should be on the ground, plus or minus. No powers, no multiplication is allowed in mathematics. Okay, that's why I request you to go back and refer the playlist for the polar curves. That will be very helpful in solving these questions. Okay, now we have log r raised to n is equal to log a raised to n into cosine theta. Fine. Now, first, we have log of again r raised to n is equal to what is this? Log a into b. The property of logarithm is log a into b is log a plus log b. Series a raised to n is a into this b. So we have again log a raised to n plus log of b. I'm solving each and every step here so that you don't get confused. Again, log r raised to n, okay, is nothing but what's the property? Log of a raised to k is k log a, a very powerful property of logarithm. Log a raised to k is k log a. A raised to k is k log a. The power comes down. Log r raised to n is n log r. Pay attention to my words, lend your ears carefully so that everything goes and settle here. Okay, please practice with me. So, n log r. Again, log a raised to n is log a raised to n plus log of cos of n theta. Now we can happily differentiate it to get the results. So before differentiating it with respect to theta, if you are new to this channel, then please do hit the subscribe button right now. That is going to give me the more and more courage to make more such effective videos for you, even though I am going through critical health condition and I'm in pain. And apart more from subscribing, please do share these videos with your friends, your classmates, your study groups as much as possible so that each and everyone gets benefit from it. So let's now differentiate with respect to theta. So we have differentiate with respect to theta. Okay, so we can write n into what is differential log r? See, we are differentiating with respect to theta here. Chain rule. Log r with respect to theta. Differential log r is what? 1 by r. Again with respect to theta is dr by d theta equals, now n log a is to n. Okay, what is it? Sorry, n log a. What is it? Differential log a is 0. See, be careful here. Many people know, I've seen in examinations, they know differential log x 1 by x. See, x is a variable, y is a variable. Just simply write and come log of differential log is 1 by. You won't get marks. Remember, a is a constant. So always a, b, c, m, n, o, p, q, r, s, t, everything is what? 0. So differential log is what? 0. I write here plus. Again now, differentiation of log of cos of n theta. Again for the basics. Differentiation of log x is 1 by x. So, mathematics only standard function is allowed. Only log x is 1 by x. Apart from that, again differentiate. See here, log of x is 1 by x. So, log of cosine theta is 1 by cosine theta. Again into differentiation of cosine theta is minus sine n theta into, finally again it's not plain theta, it's n theta. Again chain rule, differentiation of n theta is into n, because differential theta is 0 with respect to theta. So n cancels here. So we have here 1 by r dr by d theta equals, I can write this as, see here, n cancels, minus tan of n theta. Am I right? Okay. Now, the next step here is what? Remember, we are finding the orthogonal trajectories for polar curves. And as I discussed in the method a while ago, after differentiating with respect to theta, what is the concept here? For finding the OT for a family of polar curves, we replace dr by d theta by minus r square d theta by dr. What's that again? Listen to me. Replace dr by d theta by minus r square d theta by dr. I'll better write here. So now replace dr by d theta by minus r square d theta by dr. So replace this. Okay. Now let's write it here. That implies we have 1 by r into, replace dr by d theta. In place of dr by d theta, you put what? Minus r square d theta by dr equals minus tan of m theta. Minus tan of m theta. Fine. So r cancels. Now minus minus also cancels here. If you see here carefully, see this r and this r cancels, and this minus minus also cancels. Okay. So we can write r d theta by dr equals tan of n theta. Fine. Okay. Or now we have this equation here. What is the equation? R d theta by dr is equal to tan of n theta. Now we need to solve the equation to find the OT. So let's separate the theta and r terms here to check whatever equation is and how we can solve it. Now this will be now I can write it as d theta whole divided by tan of n theta, take this side, is equal to dr by r. Okay, so it's a best practice to take r first, r theta, the sequence follows. So I'll write, therefore that implies dr by r equals to, what is 1 by tan theta? See, I'm taking dr by theta first here, so it will be easy. You can take like this also, no issue, but it will be easy to get a solution in a standard form. Okay, so I take dr by r. Understood this stuff? I'm separating the variables here. See, d theta by, for a clear understanding, I took this down, the dr goes this side, r comes down. Simple mathematics. I'm not doing any special things here. Now, dr by r is equal to, what is 1 by tan? 1 by tan is cot. What is that? 1 by tan theta is cot theta. But here is tan n theta. Be careful here. Be careful here. You have the habit of making mistakes, so be careful here. 1 by tan is cot. So we have cot of n theta into d theta. Right? Therefore, the solution, or that implies, I write here, that implies dr by r minus cot of n theta. I think I forgot one thing here. Yeah, I forgot, into d theta. Yeah, cot n theta d theta, sorry, d theta equals 0. So tell me, dr r theta d theta. So what is the solution? Simple integration. Okay, all terms are been separated. So the solution is integration of dr by r minus integration of cot of n theta d theta is equal to c. The constant of integration. What is integration of 1 by r? It's log r minus integration of cot of n theta. See, integration of cot theta. I have discussed this in some previous videos also. Again, listen to me carefully. There are some simple integrations to be remembered here. One of that is integration of cot theta is log sin theta. Again, I repeat, integration of cot theta is log sin theta. See, when you are listening to me and solving along with me, there is no need to memorize and all. It's my experience. The things what I tell you will automatically be fitted in here so that you can recall later. So again, integration of cot theta is log sin theta. But as I told you, in integration chain is upon. Differentiation is what? Say differentiation sin 2 theta, say it is cos 2 theta into 2. But integration is upon. As I told, integration of cot of theta is log sin theta. So integration of cot n theta is log sin n theta divided by differentiation of n theta, that is n, because theta is what? Agreed? So again, integration of cot n theta is log of sin n theta whole divided by what? N is equal to c. So better what I take, I will take the LCM here. So we have implies n log r minus log of sin of n theta is equal to nc. Okay. Now again, I can rewrite this as, I can see you have the property of log a raised to k k log a. Because see, log is there, here also log. I want log plane. Simple basics in mathematics. I want log plane here. Log a raised to k is k log a. K log a is log a raised to k. So we have log of r raised to n minus log of sin of n theta is equal to, see, nc. N is a constant, c is also constant. I will take it as better k, because the constant is a constant. You can take your wish, you can take as k, alpha, beta, gamma, whatever it is. I will take for simplicity k. Now again, that implies what? Log a minus log b. What's that again? See, we are using the principal logarithm here everywhere. Solving this applied problems is only applying the basics what you know. So in log we have 3 basics. Log a into b is log a plus log b. Log a by b is log a minus log b, and log a raised to k is k log a. So log a minus b is what? I write it better. That implies log of a minus log b, log a by b. So log of r is Tn by sine of n theta is equal to, what's that? K. See, for easy cancellation, K, we have K. I can also take it as log K because K is constant. So obviously log K is also constant. We need to do some small arrangement here that only comes from when you use your brains. That's it. Okay. And when you solve the problems, only seeing the problems won't help. See, watching it and solving along will help you solve more and more different problems. Okay. Now, log r is Tn by sin theta is equal to, this is K, right? So K will take it as again, say log K. Log alpha, here is what I take is log T because constant is a constant. Why I'm taking log T? Because see here, log and log again cancels. Okay, log K will be always a constant, doesn't matter. But here I can easily write the answer in standard form as per the OT. Okay, so see, log r strain by sin theta is equal to log K, log cancels. So we have r is Tn is equal to K into sine of n theta. That's all. So the meaning of OT is it's a family of curves. It should resemble the same family. So I have a family of curves here, r is Tn. So for that, the orthogonal trajectory is perpendicular is the same family. This is the answer. So the orthogonal trajectory for r is Tn is equal to a is Tn cos theta is r is Tn is equal to K into sin in theta. That's it. So it resembles somewhat the question. This is how you need to solve. Okay. The next problem which we are going to discuss here is find the OT of the orthogonal trajectories of a family of curves r is equal to a into 1 plus sin theta. So my polar curve here is r is equal to a into 1 plus sin theta. As we have discussed in the theory and previous problems also, when we encounter problems of polar forms, we apply log on both sides. It will be more convenient. So apply log on both sides here. So log of r is equal to log, take the whole bracket, a into 1 plus sin theta. Now see, we have, see, never open the bracket. Please remember it. Because inside a bracket is a single function. This is like, log of r equals log a and b is 1 plus sin theta. So log a plus log of p, 1 plus sin theta. Am I right? Now, the next step is we differentiate with respect to what? Theta. And always differentiation of log r is 1 by r dr by d theta. We have 1 by r dr by d theta equals log is 0 plus, again see, the chain rule. Differentiation of log of x is 1 by x. I repeat, let's go to basics here now. Differentiation of only log x is 1 by x. Apart from x, anything is there, it becomes a chain rule. So differentiation log first. Log of x 1 by x, so log of 1 plus sin theta is 1 plus sin theta. Again, inside, it's not plain theta, it's 1 plus sin theta. So differentiation of 1 plus sin theta again is 1 is 0, sin theta is what? Into cos theta. So we have this here. Now, from the theory of finding the OT of polar curves, the concept is the main part is we replace dr by d theta by minus r square d theta by dr. Listen carefully, you people may make mistake here. Okay. Always the method of finding the OT is for polar curve is replace dr by d theta by minus r square d theta by dr. So right here now, so we replace dr by d theta by minus r square d theta by dr. Okay, so please, it's better you practice along with me, okay, so that don't miss any step. Fine. Now we replace it here. So in place of dr by d theta, we write minus r square d theta by dr equals what we have here, cos theta divided by 1 plus sin theta. Now see, simply r and r cancels here. R and R cancels. So we have This as that implies minus r d theta by dr equals cos theta upon whole divided by 1 plus sin theta. Okay, now for this expression, we need to make a differential equation and solve it to form the given OT for the curve. So how to do it? So we better separate, there is theta and there is d theta and dr and r and theta. We separate d theta, dr and dr and r and theta one side. Okay, so we separate it now. So once we do it, so we get, see, very simple, 1 plus sin theta, take it this side. Okay, cos theta comes down, fine, cos theta comes down into d theta equals, see, dr, when I cross multiply, dr will go top and this r which is there will come down and there is a minus sign here. Okay, this is what we get. So since the question is given r is equal to a into 1 plus cos sin theta, the expression, so the OT should be also in the same form. So for that reason, I'll take r first. So when I take this first here only, is equal to minus. When I take minus this side, it becomes a plus. Simple mathematics. So I take this side. So we have dr by r plus 1 plus sin theta by cos theta into d theta equals 0. Now both the variables r and theta are separated. D theta, theta terms, dr, r terms. So what is the solution now? Simple integration. That's it. So we have integration of dr by r plus integration of 1 plus sin theta by cos theta d theta equals c. When I integrate, there's a constant c here. So again I will simplify this as dr by r plus c. Simple basic mathematical stuff. Again, a plus b by c is a by c plus b by c. So the concept of doing integration is making things simpler here. Okay, and for your VTU syllabus, you need to memorize some 5 to 6 integral formulas in this chapter, which are written here. Now see, dr by r, again what I told, a plus b by c is a by c plus b by c. So when a denominator is a whole factor, I can simply write 1 by cos theta plus sin theta by cos theta. What is 1 by cos? It is 1 by cos is secant theta plus again sin by cos is what? Tan theta. D theta equals c. Now integrate. So we have, I directly integrate here, integration of, or I write here first, integration of dr by r plus integration of secant theta d theta plus integration of tan theta d theta equals c. Now, as you know, integration of 1 by r is log r. You are aware of it. But this see, one more integration to remember. Integration of secant theta is what? Log secant theta plus tan theta. Correct. Integration of secant theta is log secant theta plus tan theta. There are so very few integrals you need to remember here for solving the OT in polar forms. See, simple integration like sin theta is minus cos theta, integration of cos theta is sin theta, integration of 1 by x is log x, as you know, and integration of cot theta, as you discussed in the previous problem, is nothing but log of sin theta. Fine. And integration of secant theta is log secant theta plus tan theta. One more here is integration of tan theta is log secant theta. That's it. Okay. So remember here, when you listen to me, when you practice with me, listen to the words which I say and you repeat it more and more times. You need not memorize it. Those things will be imprinted in your minds. Again, integration of secant theta is what? Log of secant theta plus tan theta, log of secant theta plus tan theta, and integration of tan theta is log of secant theta and equals to, that is equal to c. Now again, see, log a plus b plus log c, log a plus log b plus log c. What is log a into b? Log a plus log b. So log a plus log b plus log c is log abc. So we have this as log of r into, what is it? Log a into B is log A plus log B. That is log A plus log B is log A into B. So log A plus log B plus log C inside the bracket is a single function is R into secant theta plus tan theta into secant theta. So for my simplification, you have to make some adjustment as I told you. C I'll take it as what? Log K. Because C is a constant, obviously log K is a constant is a constant, doesn't matter, but it will help us in simplification and getting to these forms, similar form. Okay, now log cancels here, log and log cancels, it helped us. Now we have R into bracket secant theta plus tan theta into again secant theta is equal to K. This is my orthogonal trajectory, but as I mentioned, it's a orthogonal trajectories are concentric curves. It should look, see we have question as R is equal to A into 1 plus sin theta. The output should also be look similar to that. Obviously this answer is, we have the answer, but to get full marks, it should represent some form like this. In plus or minus, it may alter here and there. Okay. So what shall I do here? Make use of trigonometry basics. So we have R into, what is your secant theta? Secant theta is written as 1 by cos theta. Because I want to answer also sin the cos form. Okay. Tan theta is sin theta by cos theta. Secant theta is again 1 by cos theta is equal to K. That implies, okay, take the LCM, R into, take the LCM 1 plus sin theta upon cos theta into 1 by cos theta is equal to K. So that implies again R into 1 plus, I am doing each and every step here so that you don't get confused, upon cos square theta, am I right, is equal to K. Because cos into cos square. Now again, I can rewrite this as R into 1 plus sin theta whole divided. So again, what is cos square theta? Cos square is 1 minus sin square theta. And what is 1 minus sin square theta? 1 plus sin theta into 1 minus sin theta. A square minus B square is A plus B minus B. So cos square theta is 1 minus sin square theta. And 1 minus sin square theta is 1 plus sin theta into 1 minus sin theta. So we have 1 plus sin theta into 1 minus sin theta. Beautiful. Is equal to K. Here again what happened? 1 plus sin cancels. So finally we have R is equal to, take that side, K into 1 minus sin theta. See where we landed here using trigonometrical expressions. So the given question was, find the OT for the family of curve R is equal to 1 plus sin theta, and the OT for that curve we are getting as R is equal to K is a constant, K into 1 minus sin theta is the required OT for this R is equal to 1 plus sin theta. But it needs practice to become perfect. So my dear friends, that's all for today's session. I hope you clearly understood how to find the orthogonal trajectories for the family of polar curves. If you have any other queries or any you want me to solve any other question, then please drop a comment below. I would be glad to answer. So if you like the way I teach, so please do subscribe, share this video with your friends, your classmates, your study groups as much as possible. Prepare well, stay focused and study smart. Keep learning, keep doing. See you in the next one. Bye.